It's all good.
Hope you enjoyed your break.
It was amazing.
Thanks. Or I mean, that's not. That was not a good response to that. So, yeah, sorry, guy. I gotta go. I'm done. All right. So, cool. So now we want to spawn the little boys from, instead of spawning it from the actor's location plus the actor forward vector, we kind of want to spawn it from the camera's location and camera forward. So then they will spawn sort of in the middle of the screen all the time. So how does do? Well, I would just sort of, you know, in the location, let's maybe try to do like camera get world location, get component location. There we go. So here we have a nice little function, return location of the component in world space. So this little function will give us the location of a component in world space. Excuse me. So this is, you know, in Unity, a component doesn't have a world location, right? It's just a transform that has a location. But again, in Unreal, each scene component has its own unique discrete location and rotation. So we do get component location, and then we want to add that. We want to add in the camera's forward vector. So then again, we can just do get forward vector. There we go. So here we have the forward vector. And then I'm going to offset that by, 100 was a little bit much. Let's do 80. Like almost 1 meter. So now instead of setting the location to be the owner, or sorry, the owner, instead of setting the location to be the actor's location, we're setting it to be the camera's location plus the camera's forward vector times a little bit. And the rotation, we can sort of do the same thing here. We can replace this with setting the rotation to be the camera's rotation. Which, you know, it will be the same thing, but it looks a little bit cleaner, I think. So we can just do get component rotation, maybe? Yeah, is there a component quad? Ah, there we go. Sweet. So get component quad will get the world rotation of the component and return it as a quaternion. Very good. So let's try and compile and see what happens. Okay, so if we play, then... amazing! We're shooting from the camera. Wow! Oh my god, wow! Alright. Did this make sense? The steps we did here. Umami.
Yes.
Yeah, I would say so.
Cool. So now we have a gun, and we can shoot the gun. So let's do that day, because now we're sort of littering a lot, right? It's sort of like we're just leaving trash everywhere. Also, when we shoot downwards, we still depenetrate a little bit, but I would say that's fine. So let's make it so that maybe they explode or something. I would say that, like a grenade launcher or something. So when we hit the ground, it's like, and it explodes. I think that sounds pretty cool. Sounds pretty sick, I think. So let's do that. So in the fuck projectile, when we hit something, instead of setting the velocity to 0 and disabling tick, let's just I don't know, let's begin with something simple. Let's just destroy the actor, I guess. So we'll just do destroy. So when we hit the ground, it will do, we will just kill the actor. So let's see what happens. Oh, I didn't compile. Classic. Nice. So now, yeah, when I shoot something, they just disappear right away. They disappear when they hit the ground, or they disappear when they hit the wall or something. Cool. So, but it's not that. I mean, it's not very impressive on an explosion, I would say. Like, you know, it doesn't look all that exciting. So we should probably spawn like a Niagara effect, or not Niagara effect. We should probably spawn like a particle effect or something when we hit a surface, like spawn like an explosion or something. I think that would look pretty cool. So how would we do that? Well, we could certainly do maybe spawn emitter in here in code. We could probably do something like, you know, Niagara or something. Niagara, what, I don't remember what the library is called, but something, and then spawn system or what have you. But then again, we're gonna have to add just even more references to blueprint assets, or just assets, I should say. So then we're gonna have to make like a Niagara system pointer in here that we can set to something, and it's gonna be just more and more assets that we need to reference. Because in the end, do we need to spawn it from code? Like, do we gain anything from spawning a Niagara component or Niagara is a particle system. Particle system. Do we need to spawn a particle system from code? Can't we do that from blueprints? And I would say it's actually better if we do it from blueprint, because inevitably the FX team, like the artists, are gonna wanna come in and be like, hey, this explosion you put in, it sucks ass, it's really boring, we want to add a new effect. Then all of a sudden they might want to add 2 effects, so they want to add maybe multiple particles that they spawn or something. And then it's going to be really hard for them to go into code and change what you've written because you just wanted to have it in code. So I would say this case is a perfect case of let's just put it in blueprints. It's going to be much easier to do in blueprints anyways. Then we don't have to do an asset reference, and we don't have to, you know, make it harder for everyone. So how do we do that? Well, there's multiple ways of doing it. There's probably like a billion ways. But the way I would do this, if I was working with this projectile at work, is that I would make a blueprint event. Alright? I will make a blueprint event. And what does that mean? What is a blueprint event? Well, if we go into blueprint here, into our player, and go into the event graph, remember the event graph is where all of the blueprint logic happens. We already have 3 events here. We have one event begin play, we have one event actor begin overlap, we have one event tick. So events are just kind of like functions that we can override. They are stuff that's called from C++. So begin play, for example, is called from C++. And when it's called, this event here triggers, so then we can do like print and so on. So these are events, and there's a bunch of them. If I just type event, there's like event destroyed, there's event end play, on landed, on launched, I don't even know what that is. Why is that there? Event any damage, like there's a billion events. So I would probably make another event. I would make an event for our projectile that's like on hit surface or something. That's probably what I would do. So then we make that event and we call it from C++. And then whatever Niagara effect the artist want to spawn or audio that wants to be played, they can just do that in blueprints, where it's easy to manage, it's easy to reference assets, easy to change, and everyone can do it. So that's how I would do, and that's what I'm gonna do. So I'm just gonna go in here, public, and the way we create a blueprint event is that we make the function just like any other function. So I'll call it on hit surface, or maybe on explode. That's probably a good name. And the way we declare this function as a blueprint event is to first mark it for the engine. So we first want to mark that this function is significant to the engine, which we do by calling by declaring it a U function. So now we have marked this function to be significant to the engine. It will generate reflection code for it. And then to mark it as not a function that I want to declare, or sorry, define, I would say. It's not a function I want to define in code. This is a function that it doesn't have any code attached to it in C++. It's supposed to just be an event that you can hook up to in blueprints. Then we, in the U function, write blueprint implementable event. So now, when the Unreal build system goes in and generates code for this function, it will actually generate a definition for this function for us. We don't have to generate any body for it. We just leave it as a declaration, and in the generator.h here, it will generate the code to actually call the blueprint version and do all of that magic. So when we make a blueprint implementable event, we don't need to do anything else. We just leave it like this, and all we just gotta do is call it.
What happens if we give it arguments?
Good question. Let's give it an argument. Let's give it maybe the hit results. So I'll just give it a const ref to the hits. So let's do that. So in the hit here, we would call this event. So I would call onActorate, and you just call the functions. Nothing magical more than that. Or well, I would say it is very magical that you just call the function and magic happens, and then all of a sudden it's in blueprints. But yeah, I guess that's very convenient. So yeah, we just call onActor hits. onActor hits. That's not what it was called. onExplode was. I wasn't even close to the name. So there we go. It's called onExplode. That's the name. So I call onExplode, and then I send in the f hit result here as a parameter into this. And let's compile and see what happens. It worked.
Can you have multiple things that like subscribe to that event or whatever, or is it just for that specific class?
It is just for that specific class. So it's not an event in that way of like, an event delegate. You can see it more as a virtual function, I would say, it's more like a virtual function rather than like an event delegate in that Blueprint can override it. And then if I want to inherit from this, so I would have another blueprint that inherits from this, I can override it again, and then it acts like a regular virtual function where I have to call like the super version and stuff.
Yeah, but only one thing will ever only one thing will be called ever from that thing. You don't have to like all of the things that inherit from this, I will call this function.
Yeah, exactly. It's only one function will be called somewhere in some BP. Cool. Yeah, so it's not like a delegate where it's like 10 things react at the same time. That's a good observation. But so now, if we right click here, there should be an event on explode. On explode. There's an event called event on explode. I'm in the player. I'm in the wrong BP. This fuck projectile. Fuck. Okay, so yeah, now it's in here. So we gotta open full blueprint editor. It detected that we didn't have any code written, any blueprint code, so it went into this like property only mode. So that's why we'll click this blue here, open full blueprint editor. And there will be an event called onExplodes. There it is. And like the Sweeney gods predicted, here is the f hit result that we set as a parameter for the event. So they will just show up here as output nodes on this event. We haven't really talked that much about how the blueprint language works, like how do you code stuff in here. We will do that a little bit now for this onExplode, but it's very easy. But yeah, so we can add as many parameters as we want to this event. We can add floats, we can have integers, we can have pointers, we can have whatever we want. And they will show up as parameters for the event. But so right now, we want to spawn a particle effect when we explode. So let's drag out here. So this is the exec. So this is what's being ran. This you can see this as sort of as the we're chaining together nodes, and they're being executed one after each other, one after another, and it runs with this exec pin here. So I will do spawn particle, spawn emitter. Okay. So spawning an emitter will spawn a particle emitter, and then we want to do either attach, so we can like sort of attach it to something, maybe attach it to the ground or attach it to some actor or something, or we can just spawn it at the location, and we'll just have that world location. I think at location works well right now. So now we're gonna spawn an emitter at the location, and here are the inputs to that node. So if you see that as a function call, then this is going to be the arguments to that function call. So here we have an emitter template, and that's an asset. So which type of emitter are we going to spawn? And for that, let's just do the drop down, and we conveniently have a P explosion here. So let's do that one. So now we're going to spawn a P explosion emitter. Then we have our location, and that's where to spawn this emitter. So I would say the easiest way is to just take the actor location, right? So we want to spawn this explosion where this projectile was when it hit the surface. So I'm just going to drag out from the location here. I'm just going to drag out. And then I get this little box here, and I'll just type actor location. So here we have a function called getActorLocation. So I'll just select that. So this node will be called, so it will sort of call this function and go through each of the parameters and then follow backwards to see, okay, so this location is plugged into somewhere, and then evaluate this node here. So it will be like, okay, location is supposed to be the actor location, and then we'll take the next one and so on. Rotation, don't need to care about that. Scale, don't care about that either. Auto destroy, it being true is fine, so it will just destroy when the emitter is done. Pooling method, don't need to worry about that right now. And auto activate, we want that to be true as well. So when we spawn it, we want it to immediately activate to show the emitter. Let's compile and see what happens.
Can you also like take the surface hit and kind of split that up into different parameters?
Very good idea. So that's would be another thing that we probably would do, is not do the actor location, but instead do the position of the hit. And the way we do that is that we can either drag out here and type break. So then we'll have this break hit results. And this is for structs. So all structs in Blueprint can be broken to get each individual component. So here you can see the component individual variable. So here you can see that here's all the variables for this F hit results. So here we have location, we have impact point, we have normal, impact normal, fizz material, blah, 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 all the fucking hit result things.
Cool.
We can also, if we want to do that, we can right click this, and then there's a split struct pin here, so we can do that as well, if we want to. So let's actually do that. In this case, we want the impact point. So the impact point is going to be the position of collision. So if I paint this up a little real quick. So if this is the ground, this is the surface. And then, whoops. And then here's our ball. Our sphere that we're tracing with. So one here, and I'm going to copy it. So we're sweeping, right? Okay, I can't do that. So we're sweeping, right? So we're sweeping like here. So here's the sweep. Like this. Then blocking hit is if we actually hit something. And we did, we hit the ground here. So here's the point of collision. Initial overlap means that we started the sweep being inside another collision box. So start overlap means if there's another cube here, for example, and at the very beginning of the sweep, before we even started moving, we were inside another thing, then initial overlap will be true. And this is where depenetration comes in, so that we are penetrating, we need to get out of it. Hit time is the from 0 to 1, what is the alpha of the sweep? So, you know, if we hit something right away, so we started penetrating, then time will be 0. Let's do 0. And if we hit something right at the end of the sweep, so like the last little pixel of movement, we hit something, then time will be 1. And if we hit something halfway, then it will be 0.5. So it's just sort of like how far into the sweep did it get before we hit something.
What is the default distance of the sweep?
The default distance.
Like, oh, right.
So the sweep distance is just how far the offset is, right? Because we did the sweep here. So we did the actor world offset, right? So we said move this amount, this distance here. So the hit distance will just be how far did we get into the trace before, or into the sweep before we hit something. So you can see that as time multiplied by total distance to sweep. And here are the important ones that I wanted to actually get to. Hit location. That is where was the shape when we hit something. It's not where did we hit. It is where was the shape when we hit something. So in this case, it's right here. This is the position of the sphere when we hit the surface. That is hit location. So if we did a ray trace, then yes, they would be the same thing, because a ray trace is just a line, right? So the position of the line at the impact is exactly equal to the impact point. But for a shape trace, that's not true. And here's the impact point, and that's the one we want right now. Impact point is this red little dot here. That's where we impacted the thing. What point did we touch? So that's what we want to use for our location. So I'm just going to drag that into location here. So I'm going to take the output of the surface hits, the impact point, drag it out, plug it into location. So that's where we're going to spawn the emitter. Then we have normal, and that's the normal of the hit. So that's going to be just what the surface normal was. I don't actually know what impact normal is. I don't know what the difference between these two are. It might be that normal... It might be that normal is the depenetration vector if we are initial overlap. So it might be that this is the direction to go to get out of the penetration, and this will be just the normal of the surface. But I'm not quite sure about that, so I'm gonna leave these two as one is the normal, one is the normal, and probably something else at some point. And these ones are kind of, I think these are kind of obvious. Physics material is just the physics material of the surface. So if you're walking on grass or if you're walking on ice and so on, used for audio. And then here's the actor. So which actor did we hit? Here's the component. Which component did we hit? Here's the bone name, which is if we hit the skeletal mesh, then what bone of that skeletal mesh did we collide with? Hit item, no idea. I think this is the index of the bone. I think, but don't quote me on that. I think it's the index of the bone. Face index, also not quite sure. I think this is which triangle face. I'm pretty sure that's what it is. Which triangle of the shape did we hit? The index that triangle. And then trace start and end is just if when we did the trace, what was the start point and what was the end point of the trace. So that's what those two are. Cool, we made it through F-hit results. You will never remember that, so good luck. So anyways, because I sure as hell don't remember it.
Do we need to?
No, hell no. If you needed to remember anything, then you would be fucked in Unreal. Because I sure don't. Anyways, so we're gonna spawn the emitter at this impact point then, because we want the point of contact to be where the explosion originates from. And just let's check before that it works before we take launch. Let's see what happens. Yay! Hooray! Can I get an applause, please?
Hey!
Yay! Please clap. Thank you. Thank you.
Nice.
Thanks. Thank you.
Wouldn't it make sense to spawn the explosion where the projectile is when it collides, rather than the point of where that it hits? Because it's not the wall that is exploding; it's the projectile, right? Or am I thinking weirdly?
Yeah, that's a good point. That's a good point, but it gave me a reason to explain.
Yeah, okay,
hit
that's
results.
right. Sorry.
So why don't you shut your... No, I'm just kidding. I'm just kidding. Yeah, that is true. But I just wanted to explain what the hit result was.
No, that's important.
So then I'm assuming surface hit location
dare you.
instead.
Yeah, that's true. We could have just done that instead. So yeah, if we wanted to change that, we could just go to hit location instead, because that's the sphere's location at the hit. So I could have just done that. I could have been smart and done both, but I was the dummy. but it's okay. So now it spawns a little bit above the ground. Excuse me, Jesus. Yeah, it spawns a little bit above the ground when you hit the ground and so on. So cool, and this is the way I would usually do things when it comes to interacting. When it comes to interacting with like particle effects and audio and stuff like that, I will make a blueprint event and then let the artists, and I might make a temporary something, like something that's obviously temp, but then I will just let that tell the FX artists, be like, here's an event, do whatever the fuck you want, and they'll just do spaghetti off of that event. And I tell the audio people like, okay, I made an event, just hook up to that, do whatever you want to do. So I don't have to worry about it. They have control. They can do whatever they want. They can do delays. They can do, you know, all kinds of weird stuff coming off of here, and I don't have to know about it. Highly recommend doing this. Do not. I personally hate having references to emitters and audio stuff in code because it just makes everything harder. Cool.
How expensive is the like spawning stuff in Unreal? Spawning and destroying and stuff, because in Unity we usually like try to do object pools and stuff, right? And not spawn stuff unnecessarily. Like if I would have made this in Unity, I would have probably like put the particle on the object, pulled that object, and then just call the start particle effect, and then destroy it after the particle effect has played.
Mm-hmm.
But that's just preference. But is it expensive to like instantiate, spawn things and destroy them?
I mean, yeah, it is. I mean, it costs time for sure. That's why also here there's like pooling built in to the emitter system, so you can sort of pool them manually. I mean, that's again, as you said, it's just preference. But again, like I said before, don't solve the problems you think you will have. Solve the problems that you do have. So I would actually, even though if I was like spawning every frame, I would just do that. I would just spawn every frame or whatever, how often I am spawning. And then I wouldn't start pooling until I know what is the actual cost of spawning actors in this level. Like I would pop it up on Xbox or something, do some checking and see like, okay, how many MS per frame are we actually spending on spawning, and then I would see like, okay, it is a big problem. Then I would start pooling them. But
that's a good point. And I guess in this case you get a lot of more friendliness to the artists and designers and stuff. Like they can go in, and so I don't have to like
Yeah, exactly.
That's probably a very good thing.
Yeah, it just becomes very complicated if you start worrying about that stuff too early, because it's like, I used to tell artists like, do your thing, just go as crazy as you want to, and then we'll figure out how to make it performant when it becomes a problem. That's usually how I like to think about it, but that's just me. Cool. All right, we're a little bit over, so let's take lunch, and I'll see you guys back 5 minutes past 1. So have a good lunch, guys, and see you soon. Bye.
Same to you.
Bye.